Preparing your branch circuits for each of the drives. You can see here that the 2 horsepower is 14 gauge 2-wire, and it needs a 15 amp 240 volt breaker. And your 3 horsepower is 12.2, your 5 horsepower is 10.2, and so on, all the way up to 15 horsepower. Now we do supply another 20, 25, and 30 horsepower units, and we'll specifically tell you what those are. Okay, and then these are all your sizes. So that is what you need prepared to feed the VFD for all of the ratings in there. Okay, now that you've prepared your single-phase branch circuit, we're going to look at the motor tags and make sure that the voltage on your motor is wired correctly. And in a lot of cases, you're going to have motors that are dual voltage. You can see 230, 460. And it'll have a configuration, because this is a dual voltage motor. We want to verify that the motor is actually wired to 240, not 460. I'll show you that on the inside of the junction box of the motor. Okay, so we're going to open the motor, and on most motors, there is a wire connection for high and low voltage. And each one of the numbers of the numbers on the wires, which you can see labeled right there, need to correspond to the low voltage connection. And so you can see that 6 and 3 and so on, and most of them are the same. If you can't figure that out, that's when you talk to us, but it's pretty simple. What I do is, if I see 2 lines connected with a line load to it, I can see that right here. See the 2 connected? And in the high voltage, there'll only be 1 wire connected. So that is wired for low voltage 240. Our motor is now ready for connection to the VFD. Okay, so now we are connected to the VFD, and so what we're looking at here is the motor connections. So you can see that we have the 3 leads from the VFD UVW, and they're going to the 3 leads that we've already verified that the motor is wired for 240 volt 3-phase. And we can see that the single-phase power is in L1 and L2. Now, one thing I do want to mention here is you should have 1 wire coming off of your ground and then bring all your other grounds into a pigtail here, which, you can see more clearly. We don't want you to stick all your grounds onto the 1 ground lug here. And so it's much better to make a little pigtail to get all your grounds together. Okay, so we're wired up. Let's power it up. We're going to hook up the single-phase power. And the VFD is going to start flashing, and it's going to run some tests. That's charging up the capacitor banks, and it's ready to operate once it is flashing at 50. Now, we are in factory settings, okay, and we really are bench testing here. So what we're going to do is we are going to run what's called a motor rotation. And what we're verifying is that the motor is actually spinning in the direction that the machine needs to operate in. So if it's table saw, we don't want the saw blade running backward and vice versa. And so Matt, come show us that you push that jog switch, and that's going to show you the rotation. And that only runs at 5 Hertz, so it's very slow. We can determine rotation. Okay. If we were to have to correct the rotation, we are going to switch any 2 of the 3 motor input wires from UVW. So you could switch U and V around, U and W around, W and V around, and that will change the motor rotation. And once we have motor rotation established, we can then start to program the motor tag information into the parameters and come out of factory settings. Okay, so the next set, and remember, this is 50 Hertz and we have a 60 Hertz motor. So this is only going to spin at 5/6 the speed that it should normally. But that's good for testing. So now Matt can push run and we'll bring it up to 50 hertz. Currently right now there's a ramp up speed set in factory settings to 10 seconds. You press stop and you can see it's bringing it to a break in 10 seconds. We can program those times depending on the inertia and the built-in sector. Now we did add a little video here. If you need more braking resistance, we'll show you how that is done. So one little section in here is we are allowed external brake resistors, which will take and increase the capability of the drive's built-in braking sector to put high inertia loads. Now, we don't supply specifically the brake resistors. They're too heavy. You'd have to source them locally, but we can provide you with the ohm rating and what type of brake resistor you need. So if you're stopping heavy inertia machines like band saws or big lathes, you can stop a truck by adding brake resistors. I will tell you that the majority of our customers find that the built-in braking sector is perfectly adequate even for those big machines. Okay, so what we need to do now, and the reason when I'm talking to you prior to you buying one of our VFDs is I always ask you to send me an image of the motor tag. And it's very important because we have to take that information. And in that information contains all the things that this motor loves. And so we want to put those into the VFD because the VFD also acts as a motor protection device. It takes care of all of the old school mechanical devices, and actually the importance of this tag into these electronically, because now we are not operating a mechanical machine. We're actually using a computer device here to actually manipulate the things on there. And so we have to be clear about what's coming off of this tag and putting into certain parameters that are important. Now, you don't need to really worry about it because it's dead simple. We've already checked that our voltage is correct when we wired the motor to make sure that we are in 240 volts. So now what we want to do is enter the data that's important to protect the motor from you overworking it. We'll call that overload protection. And so we want to make sure that those things are. Now Matt has made lists. If you want to pause that and save it and print it out, would be a very good idea. And this list coordinates off the information on this specific tag. And each machine will have a specific requirement. And we want here in this video to explain how to extrapolate the information off of those tags and coordinate them with the numbers on this list. And now I'll let Matt talk.
So now we're going to get into the programming. Right now it's set up for the European hertz. And you see here I have a little page written out of the important things that need to be changed. So very first we're going to do a factory reset. Because in the factory they sometimes try out the VFDs and they change some of the parameters. So I'm going to zoom in here and I'm going to go to this my list again, and if you need to pause the video and take a quick look at this list, not a problem. So I'm going to hit the escape menu button. I'm going to make it say, so use the double arrow to move the cursor. I'm going to make it say F00.1. I'm going to hit enter, and it says 500, but I'm going to change it to 010. And then I'm going to hit enter data. So that just did a factory reset. Now I'm going on to the second one. I'm going to go to the F0000. So I have to And I'm going to hit enter data. And it should say 2. Does say 2. So I'm going to hit enter data. Now I'm going to go to the F01.11. And this is the ceiling of the hertz. So we need to change that before we change any other and hit enter data. And that's set at 50 hertz. Enter data. Now, it jumps me always up one, but we have to follow this list. And we're going to change this one up to 60. And we're going to hit enter data. And now we're going to go to the motor time ramp up speed. So that one is F01.17. And from the factory, it's set for 10.0 seconds, or it's 100 tenths of a second. And I want to change this. I think this motor, we can get it up and going in maybe 8 seconds. So I'm going to change this to 80, which is 80 tenths of a second. I'm going to hit enter data. And that takes me to the F01.18, which I'm going to hit enter data right away. And I'm going to try to stop this motor. I'm going to try to stop it in 80 seconds as well, or 80 tenths of a second. So right there, I changed it to 80. I'm going to hit enter data. Now we can change that later, but we have to actually do a testing of this. So now I'm done.
Okay, stop. Stop, Matt. That's enough to test.
So now we're going to start going into the motor stuff. And here is the motor relevant stuff. The very first one is a VFD size. So we're going to go to the F15.01. And when we hit enter data, it should be a 3.7. That's 3.7 kilowatts. That's the size of this VFD. Everything is correct. Now we're at 1502. When we hit enter data, this is actually a 230 volt motor. So we're going to change that one to 230 and then hit enter data. Now we're at 1503. 1503 represents the amps of the motor. And when we hit enter, it says 16. But this is only a 14.2. So 14.2. Then we're going to hit enter data. And now we're at 1504, which is the hertz on the motor nameplate. So we're going to hit enter. It's not a 50. That's it. We're going to change it up to 60. Then hit enter data. Now we're at 1505. When we hit enter data, it says 1430, but we have a 1745. So we're going to go over 1745. We're going to hit enter data. And then the next thing is 1506. We're going to hit enter data. And this is a 4-pole motor. And whatever the poles are divided by 2, we have to enter that data. So we got that. So it is a 4-pole motor. So we're going to hit enter data. And then we're going to, the last step here is we're going to go up to 1519. We're going to hit enter data. We're going to change this to a 1. We're going to hit enter data. Then we're going to hit the escape menu. And now you'll see it says 60. And right now we're going to hit tune. And it's going to test the motor to all the information. And it says tune kind of weird. This takes up to a minute.
Right there.
And now you see at the end of the tuning, it comes back to flashing 60. If it came back with an error, you probably have some of the wiring set up wrong, or it could be a variety of things. And in the back of the manual, it'll show all the error codes. It'll say E003. This is something you're going to have to pay attention to. Right now, it's all set up. It's been tuned to the motor, and everything came back clear.